Hey everyone, welcome back to my channel, and this is the next video wherein we are going to do an amazing question of stack. Well, this particular problem is quite an important one. It's going to be using the concept. Well, the concept that we're going to be using in this particular question will be used in many of the questions of stacks only. So it's an important question and I want you to pay attention on this one. I'll be discussing the logic first, then we'll look into the code that how exactly we can do this and solve this particular problem. So I'll be using the stack approach for this question. So the problem statement is saying that we just have to keep a note of the next greater element that we've encountered, and basis on that we have to return that particular value, right? So for example, over here you can see this 1324. So for 1 we have the next latest greater element as number 3. So the number 1 has to be replaced by number 3. And for 3 we have the latest greater element as number 4. So 4 has to be placed over here. For 2 we have the number 4, and for the last element we don't have anything left, so that means we can return the -1 at the end, right? So this is one of the examples. So that means every time we just have to return the -1 at the end. And for this particular example as well, you can see that for number 6 we have the latest greatest element as a number 8, so we're taking that as the first place. Then for the number 8 we don't have any element greater than that of this one, so that means -1 is something that we can return for this particular position. For number 0 we have number 1 as the latest greater element. For number 1 we have number 3, for number 3 as -1. So that's pretty much simple, right? So this is what the problem statement is saying. So you must be thinking like, what can be the approach? There are some arrays, there are some questions based in arrays as well, that are also using the similar kind of a concept, but I believe that would not be possible for this particular question because that is asking for a different thing. So here is it's a complete different approach that we have to keep a note of, and that's what we're going to be discussing. So I'll be using the stack approach, and this is the same example that I've taken. So I'll be explaining you the logic behind it. First of all, let's try to, I'm just giving the hint. If you can think of, just give it a try and try to solve this particular question with the stack approach, and then we will proceed further. If you don't know the approach, then don't worry. But after watching this video, you'll definitely have your doubts cleared. So what exactly is the intuition behind this particular stack? Like, why do you have to pick the stack as the best data structure in order to solve this problem? The very first thing that you have to keep a note of, let me go back to this screen once again and look at the kind of the output that we need. Like, what exactly is the output the problem statement is asking us to do? See, we have to return the greater element, right? So that means even if the greater element is coming like after 5, 6, 7, or let's say 10 positions after, that also has to be considered, right? We have to check the latest greater element. Just imagine for a fact, let me open up a notepad over here, and okay, so let me just open up the Excel itself. So just imagine for a fact that you will be having something like as 5, you have 1, you have 2, you have 3, you have let's say 4, and let's say you have 6. So even for this particular thing, like you can see that for this number 5, number 6 is coming like after 3, 4, 5 places, right? So we have to consider that as well. We have to check the latest greater element because 6 is something that has to be placed in the output, right? So this means we have to keep a storage of all the elements which are coming across, and as soon as we came up with some kind of a greater element, we have to keep on taking all the elements and we have to replace those numbers with that particular greater element. So that means this is like last in first out kind of a data structure that we can keep a note of, and basis on that we can solve this particular problem because we can keep like in order to store the elements, in order to store all the elements that we have encountered so far, and if we are getting some kind of a greater element, then we have to replace all the elements that we have traversed so far, and we have to replace that. So that is only possible with the stacks, because with stacks we will be having the advantage that we will be popping one by one elements, and we will be able to replace that number with this number that we have got, the greatest one. So that's the reason we have to go with stack data structure, and this is something which we are going to be doing in this particular question. I'll tell you the approach how you can achieve that by just looking at this particular simple example. So for this particular stack that we have over here, we will be adding the elements one by one. The elements that we have to add, it's not the array elements that we have to add. We just have to add their indices. So that means this is the example which was given as an example over here on the Geeks for Geeks. So just take this 1, 3, 2, 4. These are the elements which are given to us. So we will check that whether the stack is empty or not. Yes, our stack is empty. So we'll be adding the very first element. So the element that we have to add is the index itself, right? So we'll be adding the very first index, and also the thing that we have to return as an output is the array itself, right? So we'll be adding up the we'll be having this. So this is basically our output array, and we'll be storing the elements one by one over here. But first of all, let's try to work on the stack. So for this particular stack, as you can see that we have added the very first index. Next, we will be iterating over all the elements that we for the array which is given to us. So first 0 index has been added. Next we will go to the first index. Okay, so for the first index, what do we need to check? We have to check the element which is present. So first of all, we will do the peek on this particular stack. The element which is at the top, we have to check that element. So for the 0th index, we have to check whether the element present at the 0th index, and also the index value, also the value which we are traversing at that particular point, how are these two having, like what's the relation that we have, whether 3 is greater than that of this element or not. If the element is greater than that of the element which is present at the top, we have to add that element in the output array. That's what the logic is, right? I hope this makes sense. We just have to check the element that we are traversing with the element which is at the top of the stack. If that element is greater than that of this one, we just have to insert that in the output array. And also, not just that, we have to pop that element. So that means 0 will be removed and 1 will be added over here. So now the element which is at the top of the stack, or the only element you can say, is at the index 1, which is number 3. Okay, so basically we are not adding the elements itself, we are adding the indices over here, right? Okay, so the first step is done. Let's go to the next element, which is at the index 2. We will see whether 2 is greater than that of the element which is present at the first index or not, right? So the first index is basically having 3, 2 is smaller than that of the 3. So that means we don't need to add any element inside of the stack. We just have to add its index. Index will be added. Okay, 2 is done. Let's proceed further. Go to the next index. This is the index 3. So for 3 index, what do we need to check? Whether the element present at this 3 index and the elements present at the top of the stack. So second index is 2. 4 is definitely greater than that of the 2. So that means 4 has to be added in the output array. First we will add the array, the element inside of the output array, and then we will pop out from the stack. So 2 will be taken out. Okay, now that we have the first index, whether 4 is greater than that of this particular element. So we have to do till the time our stack is empty. Okay, so now we can see that 4 is basically greater than that of the element. Okay, so yeah, that there is also one more thing that has to be keep a note of, that previously we were having this 2 inside of this particular stack, right? So 2 was something which was there, and we checked whether the 4 is greater than that of 2. So we have to add the element at the same index, at the second index, not at this index. We have to add the element at the second index. So that means 4 will be added over here and 2 will be popped out. Next we will check for this particular index, for this one index, whether the element 4 is definitely greater than that of the 3. So we will be popping out this particular index and we will be adding our 4 at this particular location. Okay, so that's what the explanation is. Let me repeat the explanation. We are just checking the index value with the stack, like whatever the element, whatever the index that we have inside this stack, whether that particular element is greater or smaller than that of the array that we are traversing with. If that is greater, just add that value for the same index and also just keep on iterating over the loop. So let me write down the code and we'll come back to this particular screen. As you can see that we are following up, we are getting the right answer. We are only left with one thing, that where exactly we have to add the -1. So that will be done inside of the code. I will come back to this particular screen. Let me write down the code till the point which we have discussed so far. Okay. So initially, first of all, we just have to have our stack. So I'll call this as stack equals new. Okay. And this is basically my stack over here. Okay. And this is going to be my something called as an integer. As we're going to be traversing through all the elements that we have inside of this particular array which is given to us. So we'll be starting with the for loop, int I equals 0, I less than n, till the end of the array I plus plus. Okay. So we're going to be iterating over this particular loop. What do we need to do? We need to start with the while loop inside of this particular for loop. And what do we need to check over here? The very first condition that we need to check if our stack is empty or not, right? If the stack is empty, we don't need to do anything, right? We can't do anything simply. And okay, so this is something which we have to check over here. Let me check the next condition. So the next condition says that whatever the element, okay, so this is something has to be done inside of the nums. Yes, whatever the element that I have at the top of the stack, if that is greater than that, if that is less, okay, if this is less than that of the element which I'm working with, I need to basically, what do we need to do? So that means whatever the element which is present at the top of the stack, if that is less than that of the element which is encountered while iterating over the for loop, we have to keep on popping the element nums I will be, and this nums s dot pop equals. I hope this makes sense to you. So basically what exactly we are doing over here, we are just checking up with the condition that if my s is empty, if my s is not empty, and also whatever the element that is present at the top of the stack, if that element is less than that of the element that we are traversing with, we have to add the element. If that is greater, then we have to add that element to the index which is present at the top of the element s dot pop. Okay. And we have to keep on doing this thing till the time this condition is meeting. Otherwise, we just have to s dot push. And what do we need to push? We need to push the index, right? So this is the main logic. This is the main crux. So I'll explain you this particular point once again. Let me write down the code first. And then after that, we will see if that is working. And then we'll be proceeding further. Okay. So as of now, we have just pushed the element inside of our stack. And if that is done till the time we are iterating over this particular, all the elements that we have inside of the array, we have to just keep on doing the same thing. Once that is done, we need to check once again if my stack is, till the time my stack is basically empty, we have to also add the -1 elements, right? So that's the reason we have to work on this one. And what we're going to be doing, we're going to be nums s dot pop, will be popping out the elements from the stack, and we'll be adding the -1 at that particular location. Once that is done, return something called as my nums. That's pretty much it, right? So let me compile this particular code. I hope this makes sense, and this is going to give us the right. Let's take a look. Let's see what's the output that we are getting. There is some kind of an error that we are getting for the line number 45, and also for the 47 s dot push. Okay, so this is basically something called as the parenthesis, is something which we have to place over here. Let me compile and run this once again. So once that will be done, I will be explaining you the, okay, this is perfectly working fine. And let me just submit this. Well, this is definitely going to work because the compilation is something that I only wanted to check. Otherwise, the logic is the same thing which we have discussed. I've written the same thing, and that is definitely going to pass all the test cases. Okay, so now this makes sense and this is pretty much clear to us. Let's go back to the Excel sheet, and over here we will be taking a look on this particular thing, because with code I want you to understand the logic that we have for this particular question. Okay, so this is coming as a little bit bigger. Let me do one thing. We zoom out a little bit, and then we will try to do the same thing over here. Okay, so basically now just take a look over here. What exactly are we doing? So initially we are just checking that whether my stack is empty or not, or whether the element which is present at the top is basically the greater one or not, right? So that's what we are checking. If the stack is empty, we are just adding up the very first value over here, right? And once the value is added over here, after adding the very first value, we will be checking whether the element s.peak, like whatever the element which is present at the top, is basically greater than or smaller than that of the element which we are traversing with nums.I. Okay, so if that is basically greater than that, means we will be taking out. Okay, so if my 3 is basically greater than that of this number 1, then I have to pop the element from the stack. So what is the element that we are popping out from the stack? This number 0. This number 0 will be removed out of the stack, and we will be placing our greater element inside of this nums array. Okay, so that is something which we have done. So that means this has been done, and our stack is basically empty. We'll come out of this particular while loop, and we'll be adding and pushing the index of that particular value that we were traversing with. Okay, now let's proceed further. We'll be going to the next element, which is number 2. 2 will be checked whether 3 is basically greater than that of the 3, whether 2 is basically greater than that of the 3 or not, which is the element at the top of the stack. It's not greater, so that means we just have to push the element. We won't be getting inside of this while loop. Okay, so 2 will be added over here. Now we'll proceed further. We'll go to the next element, which is number 4, which will be checked with the index value 2. So 4 will be checked with the index value 2, that is 2. So 4 is greater than that of the 2, so that means we'll be keep on working inside this while loop. And inside of this while loop, we'll be checking that whether till the time we are getting the numbers which are greater than that of this, we'll be popping out and we'll be placing the number 4 at that particular location. So initially we'll be storing the 4 at the second index. We'll pop this out, and we'll store the number 4 at that particular index. After that, this 1 will be popped out, and number 4 will be placed at this particular location. Okay, so that's what we are doing over here. And after that, once that is done, once the for loop is complete, we'll be coming out of this for loop. Okay, so after this, and also at the very last index when we had traversed, we have also added the index of that particular number. So that means stack is not empty after coming out of this for loop. We have this number 3 inside of this particular stack, and after coming out of this for loop, we'll be getting inside of this while loop. Till the time my stack is not empty, I will be just popping out the elements out of this stack, and we'll be adding the -1. So that means -1 will be added at this particular location. You can do the dry run for some other examples as well. If you have any kind of a doubt, you can put that in the description box. If possible, I'll make a video on that one as well, and then we can see more examples. But yes, this is the main crux. This is the main logic that we have written over here. That's the main code for this particular question. It's a pretty simple one. Once you get the logic, it will be just a piece of cake, and you will be also be able to solve the other problems. I hope this video was helpful for you. If you think that this particular question was like, if you had like any kind of a doubt, you can definitely put that in the comment box and I will reply to that and we'll discuss further if possible. So yeah, that's it from my side. That's it in this video. I hope you liked the video. Thanks for watching. See you next time.